I guess we don't have minute of silence today, so let's go ahead and talk about the assignment for today. So, in our little mini unit here, we are near the end. So, I kind of switched things up a little bit here. The two handouts you picked up today are actually the test review. So, it's got some questions about equations of lines, things like that from linear, graphing some piecewise functions, and some graphing quadratics and solving quadratics, the stuff that we have done since your last test. Your test is actually not next class. Again, I'm doing this one class earlier. Just kind of looking through here. Some of these questions, even though they're the same skills, they're asking you to kind of work some questions backwards. And so I feel like that puts a little bit more thought behind some of these questions. So I thought it would be good if we started the review today, got most of it finished, and had a chance to answer most of your questions. On Wednesday, though, I have like a 10-question worksheet where we will practice more graphing piecewise functions, and since that won't take the full class on Wednesday, that'll give us time to finish up maybe like the last page of the review and questions from the last page of the review. So that puts our test 2 classes away. In case you haven't heard, this is another B week. I'm not really sure, something to do with when they changed that eclipse day to a holiday and y'all didn't come to school. It messed with our Fridays. So I will not see you guys again on Friday. So our test is exactly a week away. So, of course, as always, I don't want to just go over these questions with you because it's easy to follow along and think that that's what you would do, but you need to try them first. So go ahead and just start with question 1. Start those questions, see how they go. Of course, don't lean on your neighbor too much. Don't lean on your notes too much. See what you actually know and understand. The website does have the solutions if you want to check as you go along. And then every, 20 minutes, 15 minutes or so, I will interrupt and offer to help you out with some of these. So again, even if we don't finish the review and all your questions today, that's okay. But 15, 20 minutes from now, you should have tried questions 1, 2, and 3. So I will give you a chance to go. I'll give you a chance to have me work out any of those you need me to. So don't postpone that stuff to Wednesday because that will be your chance to ask those questions. So again, I don't think 1, 2, and 3 should take you too long. 3 did not print out great, so I apologize. I don't know why it printed it that piecewise function horizontally. So I think you can figure out what it's saying. But of course, if you do it slightly different because you misread it, then that's not a big deal, as long as you know what you're doing. So, all right. So if you would, go ahead and number this assignment as 114, please. Both of these together are 114. And again, just go ahead and start. See which ones you're comfortable with. See which ones you're getting right. and circle the ones that you're going to want to ask about. So for front page, I don't think anyone should need more than 15 minutes. Either you know what you're doing or you don't. 15 minutes should be plenty of time there. So. Also, since I don't typically think of this, because I don't think it really should impact your studying in any sort of way, but when we do get to the test next Monday, we do allow a calculator on this test. However, the calculator is only for checking your answers. So like if you can get the answer to one of these questions on the test review, but only by doing it in your calculator, that's not going to get you points on the test. You need to be able to do it by hand, and then on the test we'll let you use a calculator to either confirm or deny, and then you can retry or not retry accordingly. So. Here's some information about your final exam schedule and stuff. Specifically for pre-cal, I have no idea about exemptions, so I don't know if you're trying to exempt, when exemptions are gonna come out or anything like that. But this is the review, and it is optional, but if you do it, I'll give you homework points, but there's some of this in here that you don't have to do because you won't be here for it, that they will, but I have all that type of stuff. Here's some information on the final exam thing. So there's the schedule for the testing. I have no idea about exemptions, when they're gonna ask for exemptions, and trying to exempt any of that. So I don't have any information like that. But then there's some stuff about our pre-cal final that's like that for you. There's some of these questions that you don't have to worry about. Stuff that you're gonna learn once you're gone. That'll be on there. So I cross that off. Not to worry about it. So, if you have other questions. Also, the review is optional, but if you, of course, you should do it to help you prepare for the final. But if you do the whole thing, I'll give you a big homework grade for it too. So, Looks like I'll need a few more minutes for the front page, so I'm going to hold off on taking questions just for a few more minutes. So stuff from the front page looks like they wanted you to remember slope-intercept form, point-slope form, brought up standard form, although you don't have to know standard form for our test, but we should go ahead and practice it if that's what it asks for. Recognizing which of those would be direct variation, and graphing a piecewise function. Again, I apologize, I don't know, I have no idea why your piecewise function printed off the way that it did, but it should look like this. It should look like a normal piecewise function. So, all right, so just from the front page, based on how much time I gave you, is there any parts of 1, number 2, or number 3 that you'd like me to go over?
C on number 1.
Number 1, C, sure. Let me... Okay, so we want it to be parallel to this line, go through this point, and they're asking for it to be in standard form. Now, regardless if it's asking for standard form, slope-intercept, point-slope, honestly, I always still just start with point-slope and hope that that's what they ask me for, because if you can do point-slope, you can change it into any of the others. So, point-slope, it's basically a formula that you need to memorize. If you wanted to go through these 2 points, plug in the y value for y1, the x value into x1, minus a negative becomes plus, minus a negative becomes plus, and then you're almost to your answer. We just have to put it in the right form after you get the slope. So what you have to remember for this question is that parallel lines have the same slope. Now, glancing at this, I have no idea what this guy's slope is. So personally, what I would do is solve him for y equals, just like if I wanted to graph it. So subtract 3x over, divide everything by -4. And the reason that slope-intercept is nice is I can see what his slope is in an instant. If his slope is 3/4 and I want a line parallel to that, I would also need a slope of 3/4. Parallel lines have the same slopes. Then, finally, I would worry about putting it in the form that they want. Again, standard form, you don't have, this is the same as general form, just kind of depends on what textbook you look at and how they call this. Again, this won't be on your test, but it doesn't hurt for you to see it. And I think there might be one question on here today that you'll see that I can tell you why some people like standard form. But standard form asks you to put the number of x's first, then the number of y's, and then set it equal to the constant. So I can do that with my point slope. I'm just going to distribute the 3/4 to get rid of the parentheses. I could subtract these x's over to the left. So now I've got the number of x's first, leave the y's there, and then if I subtract 3 from both sides, I guess that leaves a 0. So that's what I would do for standard form. But again, you don't have to memorize standard form. That's not important. I want you to do it correctly for just to follow directions, but don't worry about studying that part. Again, you might get to see the benefit of that on question 4. I don't think it's a big deal, so that's why I don't think it's worth memorizing something else for. But okay, anything specific about 1C before I take a different question? Okay, somebody else, a different part of 1, number 2, or number 3. Any of those that you would want some help on before they show up on your test next week?
Did you just do 3?
Yep. And again, we are actually going to practice this one type of question a little bit more and finish up test review stuff on Wednesday. So if you have a function that's split up into multiple pieces, this is what we call a piecewise function. I'll worry about the second part of this question later, but again, if if you struggled with graphing it because you had trouble reading it on the paper, then that's just my fault. So I wouldn't lose any sleep over it, but you need to make sure that you can do it. So I would graph this line, negative x minus 2. That's an mx plus b. So I know the y-intercept. And I know the slope. But before I'm done with this one, I'm only going to keep this part of the line. Where x is equal to negative 2, that's the closed circle, and less than negative 2. That's the stuff to the left. So I shouldn't have anything to the right of negative 2 for that part of the line. Okay, the next equation is also an mx plus b, y equals x plus 2. So again, I like point slope better than slope intercept, but slope intercept is still really good for graphing because you should instantly know the y-intercept, should instantly know the slope, and 2 seconds later have a second point using the slope. The slope is 1, count up 1, right 1. And then same thing, I would just go ahead and graph that line, and then I'll worry about these restrictions. X has to be bigger than negative 2, so that would be an open circle here, except that we're already hitting that point anyway, so it doesn't really matter if you did open or closed, you'd get lucky. And then the number's bigger than that, but then less than or equal to 2. So since it says equal to, you need a closed circle. So I need these values between negative 2 and positive 2. Nothing less than negative 2, nothing bigger than positive 2. Okay, and honestly, if you can do those two, you can do any piecewise function. It's more tedious to do a 4-piece piecewise function than a 2-piece piecewise function, but it's the same exact steps, just more work. So now I've got a horizontal line, y equals 3, but x has to be bigger than 2. Doesn't say anything about equal to, so that's an open circle. Bigger than 2, but less than or equal to 4. The equal to 4 would be a closed circle, and it's describing the points in between. Nothing to the left of 2, nothing to the right of 4. And then for the last one, we've got another mx plus b. So here's where 6 would be. Count down 1, 2, 3, right 1, 2, 3, 4. Two points determine the line, and then I would backtrack and just keep this part of it, where x is greater than 4. So it doesn't say equal to, so that would be an open circle, except that I'm already hitting that point from the last part, so it's going to include that point either way. And then stuff to the right, not the stuff to the left. So I'd say probably just making sure you're extra careful with these inequalities, making sure that you read them correctly, knowing why some are closed circles, why some are open circles, making sure that you know the inequality points to the smaller side, opens to the bigger side, and then 3 of these were mx plus b and 1 of them was horizontal line. So again, I know this is one that, to me, it's almost the same thing you guys have been doing since Algebra 1, but I know y'all struggle with it sometimes. So we'll practice more of those tomorrow. So not tomorrow, Wednesday. We got like 10 of those to practice on Wednesday, so I wouldn't feel like that's pressing just yet. Okay, let's go ahead and move on and keep on going then. So let me reset the timer. Go ahead and keep on moving towards the second page, please. And when the second timer's up, if there was something I skipped too quickly from the first page, I'd still be happy to go back and do some of those. But again, ideally, I'd love for you to finish the review and get most, if not all, of your questions answered today. But we'll just go until we run out of time, and we'll finish the rest on Wednesday. We should still get the bulk of it done today. time for another check-in here. So starting with page 2 stuff first. Anything 4, 5, or 6 you would like me to go over? Yeah. Number 5? Okay. Now also, you guys need to, I have no idea why this didn't print on yours, but you need to make sure you add these to your list there. This didn't print off with this, but I'm pretty sure we put these on the test last year, and there was a handful of people that missed them. Not a lot, but I just don't want you to have to worry about that. So question 5 is basically graphing a piecewise function, but it's a little bit harder because it's asking you to go the other direction. It's a lot easier to just be given the piecewise function and you graph it. This one's asking you to take a graph and try to write a piecewise function out of it. So when I glance at this, I see 4 different pieces. I've got a linear line here. Here's a second linear line, a third linear line, and a fourth linear line. So I'll try to do those in different colors to help you see them. So for my red piece, the first piece, I've got to come up with his equation. So I know I can calculate his slope. I can see his y-intercept. So since his slope is 4 over 6, which reduces to 2/3, his equation could be 2/3 x plus 0. Of course, I'm not going to leave the plus 0 there. But he exists when x is equal to 0 or bigger than 0. That's where he starts here. But also less than 6. And I'm not including the equal to part here because this is an open circle. So it'd be incorrect to include an equal to. Okay, the next line, which I have as purple here, is a horizontal line where y is always 6. So y equals 6 is his equation. And he exists from 6 to 8. And they look like they're both closed circles. So when x is equal to 6, when x is equal to 8, also bigger than 6 but less than 8 is when it's y equals 6. Now technically with this closed circle here, you could either include it here or you could include it with the third line. It doesn't matter which one. You just need to make sure you hit that point, one of those for x equals 8. Okay, for the third piece, what I have in gray, I can do the slope, not a problem. Down to right 4 reduces to -1/2. But the y-intercept is a little more work because you can't see where it hits the y-intercept. So one strategy is, depending on the graph, you could just take this slope and backtrack till you can see where it hits the y-intercept. Okay, and since I already included x equals 8 here, I'm not going to include x equals 8 there. It's got to be bigger than 8. And then it goes to 12. And it looks like that's a closed circle, so I'm going to include 12. Okay, and again, just like the graphing of a piecewise function, if you can write a couple parts of a piecewise function, you could certainly write a 4-piece piecewise function. Just, you got to stay careful a little bit longer. Now, I do like this last piece throws a different challenge at you because, of course, you can do rise over run. It's going down 4, right 4, which gives you a slope of -1. One way you could find the y-intercept is you could try to backtrack. Problem is, unless you're super careful, it's kind of hard to tell where it's going to hit because it's off the graph. So I'm not telling you to not do that because I think that can still work for a lot of people. But let me give one other option here. I could say, well, with this equation, let me just write the equation of the line. I already know his slope. I could pick one of these 2 points, like 16, 0. And the reason why I think this might be smarter and easier is because that leaves me y equals negative x plus 16. And so I can tell the y-intercept is going to be 16 without trying to graph it visually and hope that I do it correctly. It's a lot safer to just write you got 2 points to pick from, so you could do point slope, put it in mx plus b, and then you can be sure you know what the y-intercept is. But that's just a suggestion. Of course, on your test, it might be a good idea to do both. You know, do this, think that it's 16, and then backtrack and make sure you also think it's 16. Okay, I already included x equals 12 up here, so I should not include 12 here too. I can't hit any x value twice. That would make it not be a function. So where x is greater than 12, less than 16, and this is a closed circle, so I need to include 16. So that would be the first part of 5. Again, it's exact same as graphing a piecewise function, just backwards direction. So you have to feel pretty comfortable with the question to be able to do that. Okay, the next part, I didn't make up this review, but just kind of an interesting question that makes you think a little bit. This is why I chose to do the review today and get you started on it in case you needed to feel like you need to study it a little bit more. But rewrite the first piece, so what I did in red here, so that it would be continuous. So to be continuous, you have to remember that there's no jumps or holes in the graph. So like these 3 pieces are continuous, but because of this, these are not continuous. So what I would suggest you do is just take this guy and bump him up a little bit so that he just fits in there. And so if I was to do that, he goes from y equals 2/3 x plus 0 to y equals 2/3 x plus 2. If I just want that whole line to bump up to make this all continuous, I could just add 2 to the y-intercept. Okay, and again, I know you guys didn't have these. I have no idea. I guess we have 2 versions of this review or something, but I would think this is not something you need to study, but it came to my attention 4th period last week when we were going over this, that it didn't print off on y'all's, and I don't know why. So we did do this on 1.1 worksheet 2. The first 2 questions were like this, and again, you absolutely need to know what these are asking you to do. This just means when x is 14, what is y? So it's saying for the continuous function, so don't look at this bottom red piece, the upper red piece, but when x is 14, y is 2. When x is negative 2, y would be over here, y does not exist. When x is 6, y is 6, and when x is 10, y is right here at 5. So you need to know what that notation is asking you to do, especially if you have the graph down already. The answers are just right there. But so if you didn't remember what these were asking you to do, you probably want to write yourself a quick little sentence there. That's kind of understood that you guys understand that and are familiar with that. So just like f of x is the function with x's plugged in, f of 6 would be the function with 6's plugged in. So that gives you a y value and x is 6. Okay, anything else about 5? Anything specific about 5? Okay, what about 4 or 6?
Did you go for
Uh-huh. Okay. Number 4, identify the slope and both intercepts of 5x plus 6y equals 30 without changing to slope-intercept. Now, of course, on your test, you could still change it to slope-intercept. There's nothing wrong with that. But this is what most people call general form, the one I said you don't have to know for your test. On the front page, it called it standard form, I think, but same thing, just depends on which textbook you look at. They're just trying to show you what the benefit of general form is. General form can find x and y intercepts a tiny bit easier. Again, I don't think it makes it easy enough that you should memorize a whole nother form, but it's good for you to at least know that it exists. Because y-intercepts always have an x value of 0, and x-intercepts always have a y value of 0. If your equation's in this form, it's just easy to do that in your head. If I plug in 0 for x, 6 times y equals 30, so y must be 5. And if I plug in a 0 for y, 5x equals 30, which means x would have to be 6. So that's why some people like general form. They think finding the x and y intercept are just a little bit easier. But if you know 2 points, that's all you need for a linear line. And if you go ahead and graph it, then you can just count rise over run. He's going down 5 to go right 6, so his slope would be negative 5/6. But you would not have that type of limitation on the test. If you want to change it to slope intercept to find the x and y intercepts, then that's fine. If you want to memorize general form so that you might be able to take that shortcut to find x and y intercepts, even better, but it shouldn't be necessary. And again, we will not throw the term standard form or general form at you on the test. You don't need to know those. Or if we do, I'll put it on the board for you. Okay, so question 6, or anything from the first page that I moved on too quickly from. Number 6, okay. Okay, number 6. So both a linear function and a quadratic function are sometimes referred to as polynomial functions. We don't usually call linear a polynomial, but polynomial kind of implies that it's got a bigger exponent. But a linear function is a polynomial where the biggest degree is 1. So the biggest exponent on x would be a 1. And here's an example of a linear equation. Whereas a quadratic is going to look something like this. And his degree would be 2. Now we actually talked about this a little bit more in the next section after this test, but there's a thing called the fundamental theorem of algebra, which based on its name is pretty important, and you should actually know fundamental theorem of algebra. You probably just don't know it by name. And fundamental theorem of algebra says that whatever the degree of a polynomial is tells you how many solutions it has. Or in other words, how many roots it has. So since a quadratic is degree 2, it's guaranteed to have 2 roots. Roots, zeros, and solutions all basically mean the same thing. Zeros imply where it equals 0. Roots imply solutions to it where it equals 0. And solutions would be where it equals 0 also. Now, the roots tell us something about the parabola. The real zeros show up as x-intercepts. So if you see 2 x-intercepts, then you have 2 real roots. What I mean by real is like real numbers. 0, -2, 5, real numbers. If you have no x-intercepts, he still has 2 roots. It's just that they're both imaginary roots. So like when we did quadratic formula last week, and sometimes we would solve and get I in our answer. So those still technically solve the quadratic. They still make them equal to 0, but since they're not real roots, they don't show up as x-intercepts. And it's possible to get the same root twice. So sometimes you can only get one unique real root. If it has one x-intercept, and it's bouncing off of it, then it's just repeating itself. So just for an example, if you don't understand what that would be, that could be like x minus 5 times x minus 5. This equals 0 at 5, and this equals 0, well, let me do plus. This equals 0 at negative 5, this equals 0 at negative 5. So if you get the same solution, the same root twice, you really just have one unique root. And so you would only have one x-intercept instead of two x-intercepts. So basically, you can sum up all of what you need to know about those by real roots show up as x-intercepts, imaginary roots show up not as x-intercepts. All right, so let me give you a few more minutes to keep on going. We can try to get through at least the next page and get questions answered on that. So I will reset the timer, and same thing. If I moved on too quickly from anything from page 1 or page 2, I'll let you ask about that after I take everything from page 3 that you might have. Bless you. let's look at anything you want about page 3, please. So it looks like 7 got you to graph a quadratic and answer parts of the questions about that. All the stuff we did on the quadratic analysis page, and then it looks like three quadratics or 3 equations to solve, and it asks you to do it with factoring. So anything about question 7 or any parts of 8 you'd like me to go over with you? Okay. Anything from page 1 or 2 that I skipped too quickly that you want to go over? Oh, B8, sure. Okay, so it wants us to solve this and find the solutions to this, and it technically says factored form. So just so you guys know, on the test it'll probably say some questions you have to do this way, other questions you have to do this way, but if you wanted to have some peace of mind, you could also do this with quadratic formula and then make sure you get the same thing as this. So when I look at this one, I see the difference of 2 squares as far as factoring goes. There's something being squared on the left, 2x, something being squared on the right, 3, and difference of 2 squares always factors as a plus and a minus. Of course, you can always FOIL this to confirm that that's what would multiply back to that. Then if you set this equal to 0 and solve, you would get -3/2, and if you set this equal to 0 and solve, you get +3/2. So that should be your 2 solutions to that. And of course you could actually even plug that in, especially since we're going to let you have a calculator to check your work. You could store 3/2 in your calculator, type in 4x squared minus 9, hit enter. If it doesn't give you 0, you know something's wrong and stick with it. But if it does give you 0, then you would know it's correct and not to waste your time on that question anymore. Okay, anything else about 8b? Okay, anything else from pages 1, 2, or 3? Okay, well, assuming you're on the back page now, you still have about 17 minutes of class. So again, I don't know if that's enough time to really finish. Certainly not enough time to finish and ask a few more questions. But what I'd like you to do with your 17 minutes is try to finish this 114. If you don't finish it, it's okay. Again, your test is not next class, so you don't have to go home and finish it for homework at this point. But as always, if this stuff is not as familiar to you as it is to everybody else, if you feel like you're falling behind a little bit, you're getting a little bit concerned, then do yourself a favor and start studying a little bit. Start repracticing some of these questions. You don't need to wait till the weekend to do that. You can start now and just do a little bit each day, if that is you. So again, Wednesday, I've got like a 10-question graphing piecewise function worksheet for you to get more practice on that. And short of that, I can give you the rest of class on Wednesday to finish this review, ask questions from the last page, and study a bit. So, and then that puts our test, the class after, on Monday. So that'll come up pretty quick.